Okay, my name is Milan Gabor, and this is Danijel Grah. And today we're going to be talking about vaccinating Android. So it's good that you stay until the last presentation. So I hope you won't fall asleep. But let's start it. So actually who we are just two guys from Slovenia, although I have Hungarian family name, right? Gabor is kind of Hungarian, right? Yeah, so, but I don't understand any Hungarian words besides shore, bor, palinka, you know, and this kind of. So what we are doing, we actually love to break stuff. So especially love to play with application. And last year we have been playing with Android application a lot. So we're going to share with you also the results of our research. So how many of you have been to Slovenia already? Okay, some of them, great. So actually we have some famous Slovenian people also in IT security area. So one of them is Edward Snowden, or at least he looks like Edward Snowden. Does somebody recognize him? IT security. Before we had botnet and malware talk. Somebody wants to guess who that is? No? Actually, he's a mastermind behind the Mariposa botnet. He wrote the software that controlled more than 12 million computers around the world. Only 2 countries in the world were not affected. Does anybody want to guess which kind of 2 countries were that? Anyone? North Korea was one of them, and South Sahara was the other one that were not affected. So what we're going to talk about it today? So we're going to be a little bit talking about Android mobile apps. We're going to take a look at Hacktivity, APK. A little bit talking about static and dynamic analyzing, and definitely we're going to be presenting the stuff that we did on our research. So after 3 workshops done here at Hacktivity, we are quite also tired, so we're going to go quite fast through. So actually where we are today regarding the mobile application security. So words, but not only mobile application is quite getting complex. So if you want to just take a look at this Android ecosystem, you see that there are a lot of components, so a lot of stuff to play with it. And sometimes if you're an Android developer, it feels like this, you know. So you have a manager who talks about the due dates. You have a tester who doesn't test it right, and at the end, you know, the developers gets the most, let's say, bad words at the end. And this is the other look to the security area in a mobile application. Last year, HP Fortified did run one research, and they found out that 9 out of 10 mobile applications, they actually have some kind of issues in it. So if you want to look, there is an article online, so you can take a look at it, and you will find that actually the mobile applications suffer with the same issues that also other web applications are having. So there is also some new research. So they have compiled a list of applications that actually allow man-in-the-middle attacks. So they are not quite good at validating SSL certificates, so you can be man-in-the-middle, do some nasty stuff. Okay, so actually, if we take from that side, so there's actually a big need for testing mobile application. Not only from our customers, but I guess in Slovenia, but I guess it's the same also here in Hungary or in Europe. And if you're looking into mobile application, it's really like development field like 99, so about 15 years ago. And we can tell this from our own, from our experience. So how many of you have been to the workshop that we have been doing together with Daniel? Has somebody been? Okay, so you know, you're going to be a little bit bored in next couple of slides, but for the rest of the people that haven't been, we will just go and see how actually it's very simple and easy to get an APK, so Android application, decompile it and analyze it. So what are actually Android applications? It's just a package format, a little bit different than a zip, but still you can rename it to zip and unpack it with your WinZip, WinRAR, or whatever you use. And actually it's written in Java. So with possibility that there are some native libraries also packed into the application. But when we are talking about Java, there is one good thing with Java, that you can actually get it back. So decompile it and get pretty much the same code that it was written by the developers. And of course, there you have the other activity services and other stuff that's actually packaged into the APK, but it's not points of interest. So from development point, you got this kind of all resources, assets, source code, you compile it, you package it, and then just publish it to the Google Play, so users can actually get it. So the first thing is how to get an APK. So there's a lot of possibilities how to get it. So you can copy it from the phone, use it from the backup, use it from the web line, or even you can download it from an untrusted source. Like if you want to see what kind of file mobile Android applications are there, just type in a Google site for Hungary and file type APK, and you will get a lot of hits. There's also some possibility to go for underground forums and download APK, but I don't want to do that because really I don't want some malware or strange activities running into my phone. So if you want to decompile it, it's really simple. Just pull it from the phone, unzip it, run one command, which is found at most of the penetration testing distribution, like Ali Linux or Backbox Linux, and just run the JD GUI and you will get the source really fast. So it's not rocket science. It's very simple and very trivial things to do. Okay, so I will add a couple of slides next to Daniel, so he will warm up, and you will see that we have been playing. We're going to show it on the real case, so we're going to show it on Hacktivity mobile application for Android. Who installed it? Who has it on his phone now? 1, 2, 3, 4, 5. Did you notice something special about it? No, it's normal application. Cool. Okay.
Looks normal, but how many of you use Twitter? Nobody?
Twitter? Who's using Twitter? Did you notice something if you were using the Twitter? It was on Thursday evening. Karoli Katz is here.
And here you can see the permissions that this app requires. So I was wondering why this app requires microphone and camera. I don't know.
You should speak to microphone.
Contacts, calendar, I don't know. Is here the author of this tweet? No? Okay. Oh, sorry.
Okay, there have been interesting talk about it. If you go to Google Play, there have been interesting talk about it, but I don't understand Hungarian. Yeah, it's about the joke, because the application really requires the access to your microphone. Do you think that that application that's actually just the schedule of and other information, do you think that it needs the access to your microphone and camera and pictures and all your contacts? Would you install it if you check the permissions about it? No. Okay. So it's interesting thing, and actually here you have it from the first hand.
So after downloading the application, you have it on the disk. Then you rename it to zip and extract it, and you can see the content. That there is not much going on, but if you look inside the assets folder, you can see here that there are some pictures, I guess. But if you open this picture, it won't open. If you try to edit it, and it looks like this. Any guess what this file is? It has an extension of image, but it's not an image. So what's this? It's actually a SQLite database. So if you open this extensional image, you can see this database, and you can browse to the data. it looks like this. So I don't know why the authors of the application choose the extension of an image. So, okay.
So we have been going through on the workshop playing with that application because it was more simple and it was good case what not to do, what not to include, or also what to look inside the application. So what is else that we see when we are doing analyzing of mobile application? Definitely one thing is that sometimes you get the authentication pins in the system log. So if you're doing log grabbing from the phone and trying to log into your banking application or some other financial application, sometimes you see pins. There's also inappropriate data storage stored in SQLite databases. You get internal IPs. Is anybody here from a bank? Does anybody here from? No? No, they're gone already because they don't care about it. But sometimes, from my own experience, you can find internal IPs of address from the banks. Also hard-coded usernames, passwords, and a lot of interesting stuff. How many developers are here? Okay, some of the developers. You know, developers are kind of special species because they left sometimes beautiful things for the hackers or even penetration testing inside the code, like test examples, test usernames, passwords, URLs, where to access. So a lot of interesting stuff. For the lazy people, if you want to, let's say, analyze mobile application, you just register. One good example is there. You just upload APK and you will get really a lot of nice and interesting stuff about the mobile applications, like network traffic log, what the application is writing to the log, code decompilation, and everything that. So it's a good case if you want to play with it and you don't want to go into all the details. Okay, as I mentioned at the beginning, there's two things that if you're going for mobile application that you need to check. You will understand it when we're going to show the demos. I hope the demo gods will be nice to us. So, first is static analysis. For this thing to achieve, you need to know at least a little bit Java code. So you don't need to be Java expert, but you know to read a little bit. And you're going to help me after a couple of slides to read it, Java code. And you see, it's not that hard as some might think of. If you're doing static analysis, you don't see runtime replies. So when the application is running, you don't see it when you're going through the source code, what is sending to the server and receiving back to the server for the application. So you already see this. And you have sometimes problems if the code is obfuscated, renamed. There have been a lot of talks about this. So how the packers works and how the authors are actually hiding the content and making our lives really hard. And the most important thing is that you need to identify important segments in the code. So what should be the, let's say, important segments like encryption, writing to the logs, writing to the database, communicating, connecting to the services. So this is basically all that you need for the static analysis. So you got the APK, you download it from a phone, you decompile it, you're looking at the source code, and sometimes you need to feel lucky. So that's now is the step that I'm going to need your help a little bit. The people that have been at our workshop, they already have seen this, so they're going to be, for them this is going to be easy. But let's try to figure it out. What does this call does, or what does it send to the server? Can anybody try? Any suggestions? You see, there's saving something to the server over HTTP. Can anybody guess if you're playing a game what U or T is? U is user, yes. What would be T if you're playing a game and you want to get to the high score? Score. So this is the game that we actually took apart, and you know, at the end it's saving the score to the server. How, in this case, would you cheat if you want to be at the first place? What kind of tools would you need? What? Browser, exactly. You just put URL in the browser, you put your username, you put your score, and you win. So what else can we see in a source code? Something like this. You see there is a server, it goes through SSL, here is a path which he connects, here is a user, and here's a password. So this is also kind of you see, or if you're analyzing the Java Android applications, and this is hard-coded inside their mobile application. So also, username, passwords go with your browser, and you're in. And sometimes if you're not lucky, then you get kind of this. So not total decompilation, but kind of bytecode, which you need to a little bit understand a little bit more, but this is more advanced. Okay, so this is a static analysis. We have a code, we were looking into it, we are identifying the segments, and then we have a dynamic analysis. So what's actually under dynamic analysis? It's monitoring changing traffic with the proxy. You can do debugging, but debugging, you know, it's kind of slow. Or you can do reflection. So the normal process of this is you just start simulator or application on a mobile phone, use some kind of proxy, whatever you want, if you're on Windows or Mac OS or Linux. You run an application, and then you see log dumps, crashes, and also traffic that's going back and forth. How does it look like? So this is one request going to the server from application. You see that the mobile application are sending a lot of data, not necessary to the server. Can you guess what this would be? This segment? What's this? If you're doing networking, it's like MAC address of your wireless interface, you know. So the application is sending your MAC address to the server. I don't know if server needs it, you know, and also other stuff like which kind of version you have, which kind of Android version you are, and normally you get back from the server, the application gets back kind of this, you know. You see a lot of times that the responses or even the requests are encrypted. So you cannot see what's actually sending back and forth. So then you have a problem, you know. You can break this. Can somebody break this now in 5 minutes? Huh? Base 64? No, we tried at the workshop. It's not base 64, trust me. So you would need some extra time to decompile it. So what have we've been doing? We have not been doing any Java debugging. We use a reflection. So what is a reflection? Reflection is actually a capability or a feature of Java, so to inspect dynamically all the classes, methods, and attributes at the runtime. So if we just make it short, it's like Java looking at the Java. So inspecting our own. And there's another component that we used. It's called bean shell. It's actually a Java interpreter. It's quite small. You can script it, and it's more than likely natural, let's say, scripting language for Java. You're going to see why this is important, but the best way to show it is on a case. So if we just compare on a short why debugging versus reflection, because with the reflection we can get a really high level of view. So we have the same classes as developer had, and we got a better idea how application works. And another thing, we get interaction with the application at the real runtime. So we don't have to go step by step, but interacting in a real time. An additional feature that we have, so we have access to all variables. Even the developers defined them as private or protected, so it's only accessible from the same context or from the same class. We can get access to the all variables and change them, read them, change them, and do whatever we want. So we can also call the methods and variables and scripts, and actually we can write Java code which is transferred runtime to the application, compiled and executed in a mobile application. So that was the technology that was already there. So your reflection is there, bean shell is there, but we wanted to really something more. So we went dig deeper for like, what, month and a half, something like that, and we came up with a vaccine. So that's why it's also titled Vaccinating Android and joint application. So, Daniel.
So we develop a tool, it's called Vaccine, and what actually Vaccine does, it takes the application, it injects a service into it, and it also injects bin shell, and after that it's connecting to the application and doing stuff on it. You can see here the architecture of Vaccine. On the left side is the modified application with the injected Vaccine service and the bin shell library or interpreter. The connection is established through TCP with help of ADB, and here is the main component of Vaccine. You have the user interface, a bash script, and the manifest changer. What does the bash script? It's actually all the magic. It repackages the application. You need just remember that it transforms the class's dex file to Smalley and injects our Smalley code into it and then repackages again. And after it is done with repackaging, it installs the application, connects to it, and shows us the user interface. We like to refer to the user interface as the starting point of Vaccine dynamical analysis. And what you can do is actually all that Milan already said. You can access all the fields and variables of objects that are used at runtime. So no matter if they are private or public or protected, you can do it. You can even access methods of object, execute methods of object, and so on. Here you can see the user interface of Vaccine. The left upper part are those objects that are used at runtime by the application. If I'm clicking on the activity on an object, Vaccine will return all the fields that this object has. And below you can see the scripting part of Vaccine. Here you can write bin shell scripts or even Java source code. This will be executed at runtime in the name of the application. Also on the right side you have a watch window where you can add some variables into it, and Vaccine will refresh every 5 seconds and update the variable. So it's great for monitoring how the variables are changing during runtime. But I will show you a demo, and I need you to read this before I start.
Okay, so it's just for the educational purposes. So now playing, well, after the end, you're going to see the URL where you can get this tool and play it. We released it when? In August, after we came back from DEF CON, B-Sides. So, but the best way is to show it. It's the demo. Who likes the demos? Okay, we're going to play it real live. So please don't hack a wireless network at that moment. Otherwise, you won't see anything. So this is what you see on the screen is actually that phone. So physically phone. So if I do something, you see that it's changing. So this is the phone. So actually the application is on the phone.
Okay, let me start Vaccine.
So first demo we're going to show, it's actually a game. At workshop, some of the guys said that they are playing the game. So now they might be already cheating the game. So we're going to play the, how do you call that in Hungary? Sokirakos. Okay.
Okay.
We don't understand, but still, although that we don't understand what all the words are going to be, we will be trying to win the game in like 4 or 5 lines of code, interactively. So for the first thing, maybe you will show how that we are actually living inside the application. You see, Daniel here wrote some code, so it's just to make a toast. See that hello activity, so it's already written on the application.
So I actually executed some code at runtime. And again, you can see I'm inside of the application. If I'm clicking here on, let's say, main view activity, Vaccine will return me all the fields that this activity has. So let's start the game. Okay.
So what does it say? That it's going to be next round in like 5 seconds?
Yeah.
Yeah? Okay.
Okay, so the game is to find as many words as possible in a limited amount of time.
Can somebody tell me one word, short word, that we will try that's really running from that word? Does this work? No, no. Let's try. Let's try my Hungarian skills. Stor. No. Rut. No. Ah, rut.
But okay, if you are serious and you do your statistical analysis, you will find out that some variables hide the answer. So if I'm capable of accessing this variable, I can print it out like this. And connect to the ADB logcat, and you can see here on the system output of the phone the answers. But I can do even more.
Yeah, before that I was showing that we have been showing you that encrypted string from the burp. Actually, all the words were encrypted in that reply from the server. But now, most of the application, they are not, when they are storing inside the variables, they're not encrypted anymore. But let's see what else can we do.
We have 10 seconds left, so I will call a method that is called dump answers, and you will notice on the left upper part, the answers appear before the game is over.
So you see, here we call dump answers. So why have we showing that you need to also do static analysis? Because if you would go through the Java source code, you will sooner or later find this dump answers method. Although its code is obfuscated, it's like classes A, B, C, D, E, F, G. You don't know what's actually happening there, but from the name of the methods, you can pretty much be sure what's actually doing. So we just call one method, and it's dumping all the answer. But to be a little bit more, let's say, a little bit more fun part, we will try. So this is like 2, 4, 6, 8, 10, around 12 lines of code. We will try to win the game every time. So we're going to be top.
Actually, we will.
Top at the.
Actually, we will play a perfect game. So I will. Let's say assign my score to the maximum score, and let's execute first this. You can see the answers appeared, and they have been grayed out. So I found the answers. Just check that everything's okay. We need to wait another 40 seconds to finish the round, but you will notice in the end that we achieved how many? 247.
Yeah, it's not that hard. You see what we are doing? We found where these kind of all the results are. We are just going through them and then putting them into the right hash map, right values. So all the words have been found, and this is done in, like, as I said, 12 lines of code. Nothing more. And this code that is here is transferred to the application. It's actually executed there at the runtime, and we don't have to change APK anymore. So only first time we vaccinate it, and then application we can do whatever we want. So let's wait for another couple of seconds, and to see if, okay.
The results in 10 seconds. 5, 4, boom.
So 1, 3, 2, 1, and Hacktivity should be somewhere on the top afterwards.
Yeah.
You see? We were not playing. Actually, we are playing as a guest, but we changed it to Hacktivity. But on a score, you should be seeing this. Who's playing that game? Anybody here from the audience? One? Nobody else? Now it will get more. So, but try to be nice. You know, as I said in our disclaimer, don't do this at home. Okay, that's one possibility. But last year, CCC in December, you know, the guy named Colin Mulliner, he had a presentation there, Dynamic Dalvik Instrumentation. So we went, you know, scratching our head. Can we somehow reuse his research to make it even better? Because now we have been changing APKs. So, you know, decompiling it, injecting, although we automated the things. But let's say, what if APK will check if the APK itself has been changed? So Daniel will tell you more what we did afterwards.
So what we are doing is using Collins framework, the hijack program, and DDA ADB framework, and instead of changing APKs, we are injecting all the stuff at runtime. You need to have a rooted phone, and we are hijacking the zygote process, and after that we are hooking the Android application on start activity. This means when this method starts, we are injecting all the necessary stuff needed by vaccine, and then we are returning the program flow again to the application. But let's see this in action. You can see here I am connected to the phone, and I have already all the stuff set up, and I need to find out the bit of zygote. It's 140, and let's run it. So the hijack is now listening for the application to start, and I will try to hook the Android app on start activity of the Google Play Store. Let's run, just a second, Google Play Store. You can see library injection completed. Now I just need to run Play Store. And you can see here that I am inside the application again, without modifying it. Here are some variables inside. I can even execute some code, for example, like this. Let's execute. And you can see the package name that I am actually running in. It's command ring embedding, which is the package name of Google Play Store. So that's it. I'm actually on the application without changing it. Just a second to close this.
Okay, so we found another way without changing APKs. It's true that it's a little bit different, you know, because if you're changing APK, you don't need any rooted phone. So you can do on your tablet without any rooting your phone. So, but you need to have downloaded, modified, and uploaded to the phone yourself. If you're going through the Android, you need to have a little bit more knowledge because it's low, really low level, and you have to have rooted phone, especially because it's injecting shared libraries and setting up the environment. It's not that easy as it just running the script. Okay, so there are definitely changes ahead. We got today one question: if we plan to sell this kind of application. Well, no, it's actually up there on a GitHub. It's not only for Android. So we tested this year. One customer requested to do the penetration test with the Oracle Forms. So in half a day, we change it. We reprogram it to work also with the Oracle Forms, and we successfully inject the inside. And we have some crazy ideas, like, you know, does somebody plays Minecraft? One. You know, my son also plays Minecraft, you know. One day he came home, you know, said, I want to hack Minecraft. I said, well, I got a perfect tool for you. So Minecraft maybe because it's Java, you know, you can be injecting inside and playing some interesting stuff doing, but there are a lot of other possible usage. Or also, as we showed them, maybe there's an ultimate cheating platform. You know, just to cheat in 4 lines of code, it's not that bad. Okay, just final thoughts before we close up our speech, but we still have one demo because you're going to see what else is possible. Okay, it's just one script, so small GUI tool. Daniel says that never is going to be finished. It definitely can help testers and researchers, also hackers and cheaters, because every time you have good guys and the bad guys. And definitely we are open for suggestions, improvements, and comments. So if you have something, just let us know. But as I said, we have been to Vegas, And you cannot go to Vegas without playing some games with the cards or
some gambling.
So gambling, yeah. So we're gonna show you one demo, and it's gonna be a demo with Blackjack. Somebody plays Blackjack? Yeah, 1, 2, 2. Okay, so you're gonna help me because I don't play it. I don't know the rules. So you're gonna be if I hit or stand or split or something like that. Okay. So Daniel.
Okay, I will now run Blackjack application. Just a second. Hopefully it will run. No, it will run. Just a second. Try again. Okay.
Okay, I will be the gambler.
But let's connect to it with Vaccine.
Okay, I won't be updating the game because if I update the game, I will be losing all functionality that we injected inside. So you see,
I will copy this code here. Just a second. The phone is old and it's not responding so well. And what I will do here inside, it's actually putting some resources into the hash map. Then I'm going to display the next 4 cards in ADB Locket, and I will also replace the deal button or generate hit card button with the next card.
Okay, let me sit somewhere, buy into the game.
Just a second to connect again.
Okay, see, I'm that guy here, sitting there, here. So playing with that, So, you run it already?
No.
Okay, now you see we have a deal button here, clear button, and what should I do? Okay, deal. Okay, Daniel is now going to be executing the.
Okay, let's execute.
The script.
And you can now see the next 4 cards.
You see?
And also the replace hit button with the next card.
So do you think if you see the next 4 cards or next 10 cards at the Blackjack, would it help? Does it help if you know what's next coming? Huh? Just a little bit, you know? Okay, but it's better than nothing, right?
Okay, let's deal again.
And here you see the all next for the cards. So now it's next going to be 8 of hearts. So 8 of hearts, what was it? So next going to be 3 of club.
Should I take it?
You see, we changed the runtime, we changed the application. There was a card. So that's why it was a so big Java code, because we were taking out from the resources and displaying it, because it's a lot easier to see the cards there than to go look into the logs, logcat. You see there's an ace, so if you want to stand, then it's ace. So that's why I said, remember at the beginning that the developers are kind of special species? Why? Why do you think? Why do you think they're sending 4 or 50 next cards? Any clues? What? You get the perfect card, yeah, but any other reasons why they are selling? Why they are sending the whole pack of future cards? Is it optimization? Huh? Debugging in production, maybe, or maybe it's if you're going for some, let's say, large and heavy traffic, then you send in one request and you send in one reply back. So optimization is one part, because otherwise you would have to go for each card on a server, and this takes some time and takes some resources. Okay. But as you've seen, if you just go to the source code, what actually we did it with that, you see that it's not pretty complicated. Here we are just putting all the cards. So in the deck there is like 52 cards. We are building the hash map, so this is pretty same. And here's the magic that does. So here we put next 4 cards, so we are getting them into
and also
output.
Creating a thread that prints out every second the next 4 cards.
So it's not that much, but you need to know how to analyze the static Java source code to get this, because you need to know where actually these variables with the cards and next cards and other cards are stored. Okay. Okay. Since we are the last one, I know you want to go home, I want to go home, everybody want to go home. So are there any questions? I know it's the same in Slovenia. Okay, one question. Yes.
Will this work with regular Java applications as well on the website?
Sorry?
Will this reflection method work
Yeah.
with any Java applications running on the
Yeah, if the application is Java, yes. Yes. It will work with an applet, with a standalone application. My wish is to inject into SAP. If you want to live in SAP, that would be, the very good. As I said, we have been injecting into Oracle Forms, and it was successful.
Because reflection is Java feature. It's implemented in the language.
So. We tried also other tools. There have been Java Snoop and tools that you can actually inject into it, or even attach to the Java process, but we found out that they are not working with the, let's say, current version of Java. We actually also mailed to the authors. We didn't get any reply back, so we played on our own. So you can find the vaccine here. I promise it's clean. It's not infected with anything, so it's meant to infect other application. And if you have some questions, you can find us on Twitter. Another question, or should we go home? Okay, thank you very much. I hope you enjoy it.